So we're going to look at probability here, and one of the formulas I've put up here on the screen is something that we'll keep coming back to. So probability is equal to the number of ways an event will happen divided by the number of ways all events happen. And that's something we need to remember and take on board. So we look at how we consider a coin that is tossed 3 times. How many different outcomes are there? And don't forget, with a coin you get a head or tail every time you toss it. We've done this before, and this is what we get. And altogether there's 8 different ways, 8 possible outcomes. You can either have head, head, head at the top, head, head, tail, head, tail, head, tail, tail. Just reading them down the list. Tail, head, head, tail, head, tail, 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 head, or tail, tail, tail. So one of the questions we get asked is, what's the probability of getting any combination of this, of heads and tails, with a coin that's tossed 3 times? So this question says, what is the probability of getting 3 heads when a coin is tossed 3 times? Go back to the formula here, and the formula clearly says the number of ways an event happens. Well, we're looking for when 3 heads will happen, and we know it only happens there. So the probability of 3 heads is going to equal the number of ways the event happens. Well, how many ways can 3 heads happen? 1. And how many ways can all events happen, which is the bottom of the fraction? Well, you'll see here there's 8 different outcomes. So therefore the number of ways that all events happen is 8. And therefore the probability is 1 over 8. Probabilities are also written as percentages, and if you do 1 divided by 8, you get 0.125, which equals 12.5%. So this question says, what is the probability of getting exactly 2 heads when a coin is tossed 3 times? So again, we go back to what is our formula. Our formula says the number of ways an event will happen divided by the number of ways all events happen. So how many ways can we get 2 heads when we toss it 3 times? Order doesn't matter here. We can get 2 heads anytime. There's 2 heads there, there's 2 heads there, and there's 2 heads there. So right now the probability of 2 heads is going to equal the number of ways the event can happen, which is 1, 2, 3, divided by the number of ways all events happen, which we know is 8. 3 divided by 8 is 0.375, or 37.5%. This question here says, find the probability of getting at least 1 head. What does at least 1 head mean? At least 1 head means you get 1 head, 2 heads, or 3 heads. So let's go through this now. So probability of at least 1 head, so I can write this properly, equals the number of ways it can happen. Well, we've got quite a few here. There's 1 there, 1 there. That's 1 head, 2 head counts, 1 head, that. And we're going to add all those together. And if you add them up, 1 plus 1 plus 1 plus 1, you get 7 outcomes. It can happen, divided by the total number of outcomes, which again is 8. 7 divided by 8 is going to be 87.5%. Put a percent on that. So question here, a bag contains 3 red balls and 4 blue balls. Find the probability for drawing out a red ball. So what we've got here is a little tree diagram here. We've got red and blue. And red is there and blue is there. And we know we've got 7 balls altogether. So probability of red is going to be the number of ways we can pull out a red ball. We know there's 3 and we're going to choose 1. So it's actually we can put some combinations in here, see? 3, choose 1, divided by how many balls are there altogether? 7. Well, that's 7, choose 1. So it's fairly easy to work out this, as there's 3 red balls and there's 7 balls altogether, so the probability is going to be 3 over 7. So if we were to put this on a little spider diagram here, the probability of red would be 3 over 7. The probability of blue, therefore, would be 4 over 7. And we're going to use that in a minute to do our next question. So, this little extension question is find the probability of drawing 2 red balls. But the condition is I replace the first ball after selecting it. So really, there's 7 balls to begin with. I draw one out. I want to find the probability of it being red. I put that red back in, so there's still 7 balls. So it's an interesting problem because we actually go to something in a minute which is going to be, so there's red, just change the colours here, and I put that ball back in again and I choose another ball. Now of course we're looking for red, red, but there's obviously lots of other combinations that could happen. So altogether there's 4 outcomes, aren't there? There's red, red, red followed by blue, blue followed by red, and a blue, blue. And we know that the probability of red is 3/7, because we did that in the first question. When I put that red back in, the probability of another red is also 3/7. And what I want is red and another red. So it's the probability of red, first one. The probability of 2 reds is going to equal the probability of the first red times the probability of the second red, because I want one event and I want the other event. So it's 3 over 7 times 3 over 7, which equals 9 over 49. So the probability of getting 2 reds is 9 over 49. That's with replacement. So a question to tell you, 3 red and 4 blue at the top there, you see? 3 red and 4 blue. So the question says, find the probability of getting 2 red balls if I do not replace the first ball. So let's go back to our diagram again. We've got red, blue, and then red, blue. And I'm still looking for 2 reds. So I still want that top line there. But the difference is now that the probabilities are going to change slightly. The probability of getting a red is 3 over 7. And the probability of getting blue is 4 over 7. But if I take a red out and then don't replace it, now I've actually got 2 red balls and 6 altogether. So remember we started off with 3 red and 4 blue. That's what we started off with the question to begin with. Go back. So for this question, if I take a red out and don't replace it, now there's 2 reds, and of course altogether there's 6 balls. So the probability changes now to 2 out of 6 for the second red. So the probability now of 2 reds without replacement, so we're not replacing it, is still multiplied because I want this red and I want that red, is going to be 3 over 7 times 2 over 6, which is going to be 6 over 42. And that will reduce, you see 6 goes into both, top and bottom, 6 into 6 goes 1, and 6 into 42 goes 7, so 1 over 7. So a couple of questions here to do on your own. First question that's top of the page, replacement, so that means where the first ball is put back in into the pack, so you've got 7 balls each time, and you want to find the probability of a red followed by a blue, that should be easy. And then number 2, one of each colour, so it could be a red followed by a blue, or a blue followed by a red. Now the key word there is or, so you need to work out that somewhere along the line you're going to add some probabilities together. And then you can do the same for the second bit without replacement, where you've got 7 balls to begin with. You take a ball out, now there's only 6 left, and you want to find the probability of a blue followed by a red, and then number 2, one of each colour again. So it could be red followed by a blue, or blue followed by a red, or means we're going to add some probabilities together. Work those 2 questions out and we should be good to understand a bit more, and we'll go review in class.